I need a way to automatically turn on this dust collection system anytime I use the woodworking tools here in my workshop. But all of the existing solutions I found were too expensive and not customizable. I really don't want to spend $50 or $60 on something that doesn't work the way I want it to. So let's see if I can find a way to use these $8 smart switches to turn on my dust collection system. But first, let's rewind the clock to the beginning of this story. Back in early 2018, I built a shop vac auto switch. I could plug in any tool alongside my shop vac, and as soon as the tool would turn on, the shop vac would also turn on, collecting all of the fine dust particles so that they didn't end up in my lungs. It was a very simple design, but it had one major limitation. The tool and the shop vac had to be plugged in at the same location. So ever since I completed that project, I wanted to do a second iteration where a shop vac or even a dust collection system could be controlled independently from any tool across the room. Instead of using a current sensor read by an Arduino board, which then controls a relay module like I did back in 2018, this time around I'm going to use a smart plug. This is the Sonoff S31, and the reason I chose this smart plug is that it can measure the power being drawn by the tool that is plugged into it. The other reason I chose the Sonoff S31 is that it has an ESP Wi-Fi microcontroller. I can write and flash custom firmware on this device to get it to do whatever I need. Before I can flash this with custom firmware, I need to open it up. So I'm going to use a little tool like this, and I'm going to open up the case on the edge like this. Ooh, that just popped off. And then once I've got that open, I can slide these little pieces out here like this. By removing those pieces, I now can remove the screws. And now this just pulls right out, and that reveals a little programming header right here on the edge of this PCB. This is a pretty typical UART programming header. It needs 4 signals: power, ground, TX, and RX. The most important thing to remember when you're programming something with UART is that the TX pin on the programming side needs to connect to the RX pin on the target side. Likewise, the RX pin on the programmer needs to be connected to the TX pin on the target. Now I need to figure out the best way to connect those signals on the programmer to the Sonoff S31. I've got a few options here. A lot of the tutorials on the internet will show people soldering jumper wires directly to these test points. I think that would work fine if you're just doing one of these, but I plan on doing many, and I think I have a much better solution. I picked up this little pogo pin probe clip on DigiKey, and it is perfect for this situation. All I need to do is to clip the pogo pins over the programming pads. From there, I can just connect jumper wires from the probe clip to my programmer. This is so much faster and cleaner than having to solder jumper wires to each board that you need to program. I've gone back and forth on how I want to approach the firmware portion of this project. I've spent some time talking to some friends of mine, Ian and Jonathan, who have a lot more experience in home automation than I do. They actually started out as channel members, but over the last couple of years, we've actually become really close friends. So they recommended that I get a Raspberry Pi and install Home Assistant on the Raspberry Pi so that I can start setting up this system. The best way to get an ESP microcontroller like this to talk with Home Assistant is by flashing a custom firmware called ESP Home. Now that I have Home Assistant installed on the Raspberry Pi and I have ESP Home added as an add-on within Home Assistant, I can go to the dashboard and I'll click on New Device. From there, I'll name it Table Saw, and I'll click Continue so that it creates a basic configuration. This basic configuration creates a YAML file. The YAML file is just a text file written in a markup language, and it tells ESP Home exactly what to do to write the firmware for my device. Fortunately, I don't have to write this YAML file from scratch, because if I go to the ESP Home website and I search for Sonoff S31, there's already a complete configuration file written for the Sonoff S31. So I'll just copy that entire configuration file, and I'll go back to ESP Home, and I'll click on my table saw configuration and click Edit. This opens up the current YAML file. All I need to do is to select all, delete what's there, and paste that Sonoff S31 configuration. The other thing I want to change is the name of this device. So you want to have a unique name for each device on your Home Assistant network, so I'm just going to name this Table Saw. Then I can save the YAML file, and then the next step is to compile this into firmware that will be loaded onto the device. To do that properly, I'm going to click the option that is a manual download, and that's going to compile the binary, and then once it's done, it will save it as a binary file on my computer, and then in the next step, I can load that onto the device. This can take quite a while depending on the hardware you have running Home Assistant. In my case, I'm running a Raspberry Pi, and compiling code can take 20 or 30 minutes sometimes. Now that I have a compiled binary file saved to my computer, it's time to put that on the actual ESP device. So I'm going to use ESP Home Web. This next step can be a little bit tricky. I'm going to hold down the button on the Sonoff S31 while I attach the probe clip. This is going to put it into bootloader mode and get it ready for us to load code. I can't release the button until this is starting to program. So I'm going to click connect and I'm going to choose my COM port. And then I'm going to click install and I'm going to browse to the location where I saved the binary file. And with that file selected, I'll click install. And now it's connecting to the Sonoff S31 and it is installing. So now I can let go of the button. This is the step where the binary file is being transferred through the UART programmer into the Sonoff device. Now the configuration is installed, I can click close and I go back to Home Assistant. And if I look at my device, I can see that it's offline. The only thing I need to do to change that is do a power cycle. So I'm going to unclip and reclip my probe just to power cycle. And after a couple of seconds, the status changes to online. And that's pretty much it. This device is programmed and I can put it back together and start using it. I'm going to have several of these devices throughout my shop and I want to be able to keep track of them, so I'm going to use a label maker to print out a label for each one. The Sonoff S31 is now reassembled and I'm going to plug it into an outlet strip here just for testing purposes. Now I can go back into Home Assistant and I'm going to look at my notifications and I can see that a new device was discovered. And it asks me, do I want to add ESP Home Node table saw to my Home Assistant? Yes, I do. And now I can go into a dashboard that I set up for my dust collection and I can see that that table saw relay is there and I have a little button and I'm just going to listen carefully. I'll actually hold it up to the mic so you can hear it. Click, click. So I can control this relay from Home Assistant, which is a huge milestone for this project. The next thing I want to test is to see if I can see current or power flowing through the switch when I plug in a tool. And it's probably not practical to drag my table saw over here, but I'm going to try to grab something smaller to test it. Okay, I've got a jigsaw here and I'm going to plug it into the Sonoff switch. And as I pull the trigger, I am expecting that power to show up. Oh, first I gotta turn on the switch. Okay, the relay's on now, and now when I pull the trigger, this should go. Awesome. Did you see that? The power went up to about 300 watts as I was pulling the trigger. So now the next step is to do this all over again. I'm going to program a second Sonoff S31, but instead of making it for a tool like I did last time, this time I'm going to name it Dust Collector. Man, that was much easier the second time. So I'm going to go plug this in across the shop just for demonstration purposes, that these don't need to be right next to each other. The whole idea is that I want my dust collector on one side of the shop and any tool around should be able to turn that on. So I'm going to go plug this in and I'm going to plug in my shop vac for now, and it's loud enough that you'll be able to tell when it turns on. And just like before, I see in my notifications that I have a new device called Dust Collector. I'll hit configure, and yes, I want to add it to my Home Assistant. And once again, I see that the relay button shows up on the dust collector along with all the other power measuring information. So I'm going to test that relay and see if you can hear the dust collector turn on. Okay, so that works. So now I need to create an automation so that when the tool turns on, the dust collector also turns on, and when the tool turns off, the dust collector turns off. To create that automation, I go into Home Assistant and I go into Settings and I click on Automations and Scenes. Now right now I don't have any automations, so I'm going to create a new automation and I need a trigger. I'll click Device and I'm going to select my table saw. And now I'm going to select the table saw current. And when it changes above 2 amps, I want to turn on the dust collector. Theoretically, if the table saw current, and the table saw being the jigsaw, changes above 2 amps, it should turn on the dust collector relay. So let's try that out. Do you hear that? The dust collector turned on when the current went above 2 amps. But as you can see, there's a problem. The current went back down to 0 amps, but the dust collector is still on. So we need to fix that in the automation. So now my automation has 2 triggers. If the table saw current goes above 2 amps or if it goes below 2 amps, it's going to then go to the actions. If the dust collector relay is already on, it turns the relay off. otherwise it turns the relay on. So let's test that out. When I turn the table saw on, the current will go above 2 amps and it'll turn on the dust collector. As soon as I turn off the table saw, that current falls below 2 amps, and so the dust collector should also turn off. It worked. Did you hear that? The dust collector turned on and immediately turned off as soon as that current dropped below 2 amps. Now all I need to do is just program more of these Sonoff switches and add them to each of my tools around my shop, and then create an automation so that it turns on the dust collector when the current goes above a certain threshold. I'm standing over here in my wood shop area, and I'm going to plug in my dust collector into the Sonoff S31 switch that I programmed for it, and then after that I'll plug my table saw into the Sonoff switch that I programmed for it. With both of those things plugged in, I'm going to make some test cuts on my table saw, and I'll see if the dust collector turns on automatically. I also programmed Sonoff switches for my miter saw and my band saw and my random orbital sander. Anytime I use these tools, the dust collection system should kick on automatically. Now I know some of you are typing away in the comments section right now that I should have just bought one of these auto switches, but the last time I checked, they're actually kind of expensive, and they're the type where you have to plug in the tool and the dust collector in at the same location. Not to mention that my setup is way more customizable. I can have the dust collector stay on for X number of seconds after the tool turns off. I bought each of these Sonoff switches for about $8 each, and for a basic setup like this, all I need is 2 switches. If I want to expand this further in my shop, each additional tool just needs an $8 Sonoff switch. This is an awesome addition to my workshop because it keeps my lungs protected and I don't have to remember to turn it on manually. But it's missing something, and that's blast gates. In the next video, I'm going to show you how I designed and built these automatic blast gates that open and close when the tools turn on, so that way I don't waste suction in the areas of the workshop where it's not needed.